There's a small correction in there. Now read the question. So this is 2a. It is some misprint occurred. I will rotate through, I will rotate it by 180 degrees. So where the loop will come to this position. There's a long wire. So this distance is what? It was given 2a. So this is PQRS. I'm going to rotate it by 180 degrees. Then the loop will come to this position. Or you can say it is flipped, anything. So this will become Q and this will become R. Let it be here. So now this distance is what? 2a. So the side length is a. So this distance definitely should be a. He's asking what charge has flown through the loop. Meanwhile, so this was the square loop. How to calculate the amount of charge he is asking us to calculate. So I'll do one thing. So when I rotate this loop, this one. So flux linking the loop, will it be a constant or variable? It will be variable, no? So now a flux is linking here. Now as I rotate, what will happen to flux linking the loop? Decreases or it varies. Then again finally this is a position. So there's the initial position, there's the initial position of loop, and there's the final position of the loop. So what total charge has flown through the square loop? That's what it's asking. So now I'll do one thing. E equal to d phi by dt. I is equal to E by R, which is d phi by dt. What is I? I is the total charge flown. So delta Q by, or say dq by dt. Instead this, let me write it delta phi. So finally, what is delta Q is equal to? Delta Q equal to change in flux by the resistance of the loop. This is what delta Q is what? Charge flown through the loop. You can solve this mathematically. This will be a better idea. No, this is delta phi. Change in flux. So calculate flux in this situation. How much of flux here initial? What is the flux here? The final. How to calculate flux? I think we had a small discussion earlier. So let me take a strip and let it be at a distance x, and let this be dx. Now what is the flux linking that particular strip? d phi is equal to b into a dx. What is b equal to? Mu naught I 2 pi x a into dx. This should be equal to mu naught I a 2 pi dx by x. So let me call this as the initial flux. So what should be the limit now? 2a to 3a. In initial position, the flux linking the loop phi I should be calculated from where? From 2a to 3a. 2a to 3a, that one. So this should be equal to how much? initial flux mu naught I 2 pi log of 3 by 2. Similarly, can we calculate flux, final flux? What should be the limit? Mu naught I a 2 pi. The limit should be a to 2e. So the change in flux is what? Should be the required charge by the resistance. Will be the charge flown through the loop. So what is delta Q is equal to? Delta Q is equal to the difference in flux. Which flux will be more? The initial flux will be more, final flux, no? Take the difference of this. So this will be mu naught IA by 2 pi log 2 minus log of 3 by 2. Mu naught IA 2 pi log of 4 by 3 by resistance R. This is some like this, the charge flown through the loop and the change flux, they are related. Very important, can be asked in advance. Not only main, sometimes can be asked in advance. You can also do this by what is the other alternative method? At any arbitrary point, at arbitrary location, calculate the flux linking the loop. Not only this, some arbitrary position as it is rotating, where the plane of the loop makes some angle with XY plane. Then there you calculate the flux linking it. Then d phi by dt, then current flowing it. Then you'll get an expression for current at any time. Then what charge has flown in that interval of time. So there'll be very lengthy method. So I think this will be much easier for you. Even if I rotate the loop by 90 degrees also, this is applicable. The calculation of flux all matters here. So, but this is a generalized formula. Please do remember, very useful for you. Okay, now we'll bring the idea of the friction now.